Every statement has a number, and every reason has a corresponding number. So we start with a single statement by itself. Now, I can start with B, because it's not embedded in the compound hypothesis. Or I could have started with not F. So I'm going to start with B, and I'm going to put that together with B implies not D. Now I'm going to be doing that by putting the single statement first, but I want you to see it with the conditional on top and the single statement underneath it. I think that's easier for you to see what the conclusion is. This is a conditional. Therefore, it's either modus ponens or modus tollens. If the hypothesis is given to be true, then the conclusion must be true. And notice this looks exactly like the original. Because if I have a true hypothesis, I have to have a true conclusion. Otherwise, T implies F would have been a false conditional. And this conditional is given to be true. So in the proof, the first line, I'm going to put the single statement B. And it is given to be true. Then I'm going to put in B implies not D. Which is given to be true. Now the conclusion is not D. And that's line 3. And the reason for it is modus ponens, method of affirming in Latin. And you need the line numbers that got you that result, which is line 1 and 2. Now we're going to bring in something that has D in it. So I've used this one and I've used this one. I'm now going to go to C or D. Together with not D. Now this is a disjunction. It's an or statement. Therefore it cannot be modus ponens or modus tollens. They go with conditionals. Not D is given to be true. Everything that is in our list on the left-hand side are true. That means that D must be false. One of these two had to be true or it would not have been a true disjunction. Therefore, it must be C is true. So I'm going to bring in C or D from the given. And then C is true by disjunctive inference, and I'll let you abbreviate this one. And that refers to lines 3 and 4. Now I want to bring in something that has C in it. So I have G implies not C. Together with C from line 5. This is a conditional. The negation of the conclusion means the negation of the hypothesis is true. Because if I look at C implies not G, that's the contrapositive of the original. And remember from last week when we did truth tables, the contrapositive is logically equivalent to the conditional. Therefore, not G is the conclusion by modus tollens. So I need to bring in G implies not C. So the negation of the conclusion means the negation of the hypothesis is true, which is not G by modus Tollens. Lines 5 and 6. Now number 8. I have G in this compound hypothesis. I can't get to it with number 7. So I'm going to leave number 7 just hanging there, and I'm going to pick it up later. Now I'm going to go to these two statements and put them together. So I have not G and not J implies F together with not F. I'm going to leave not G for a few minutes. Not F is the negation of the conclusion. Therefore, the negation of the hypothesis must be true by modus tollens, because the contrapositive, which is what this is, not F implies not, parenthesis, not G and not J, is the contrapositive of the original, which we know is logically equivalent. So I'm going to bring in the statement not G and not J implies F, which is given. And I'm going to bring in the single statement not F. And now putting these together. The negation of the conclusion means the negation of the hypothesis. And do not simplify it in this step. Write it as not parenthesis, not G and not J. Because the reason for the negation of the hypothesis is modus tollens. Lines 8 and 9. But the simplification of line 10 is De Morgan's. Not G is G. A conjunction becomes a disjunction by De Morgan's. And not J is J. And that's De Morgan's only on line 10. Now, I'm going to take line 7 together with 11. So I have G or J in 11. And in line 7, I have not G. This is an or statement. It can't be modus ponens or modus tollens. They're only with a conditional. Not G is true. G then is false. One of them had to be true or this would not be a true disjunction. It must be J, which is exactly what you were supposed to be showing. So in line 12, I have J. And the reason is, which you can abbreviate, disjunctive inference, lines 7 and 11.